In this video, we will be doing lecture 6 of financial mathematics, focusing on unlimited withdrawals. Okay, so with unlimited withdrawals, you get withdrawals made infinitely, basically, at a constant rate and at an increasing rate. So with unlimited withdrawals, it's the same concept as normal withdrawals at an equal rate, but the only difference is now you're going to be making an unlimited amount of withdrawals, which is called making withdrawals in perpetuity. Okay, so perpetuity. Okay, so when you make constant rate unlimited withdrawals, the equation that you would use to get the present value would be PT, which is basically like your first payment before the withdrawals start to increase, all over I, and this would be your effective rate. Okay, just remember your interest rate, your effective rate needs to coincide with your withdrawal period. So if you're going to be withdrawing every month, your effective rate needs to be monthly. So usually how this occurs is when you have an account, an annuity or an insurance annuity when you are retired. What the insurance company would do is they would give you an amount of money every period, so maybe every year or every month until you die. So that could be unlimited withdrawals because you're not sure how much exactly these withdrawals will be, how many withdrawals there will be. Okay, and if your withdrawals are at an increasing rate, the present value would just be your PT all over I effective minus R effective. Okay, your R is just the rate of increase of your withdrawals, and again, it needs to coincide with your withdrawal period. So let's continue with an example. So here in this example, it says that monthly payments of 100 Rand starting 1 month from now, so 100 Rand is your first payment before the increase, are to be made in perpetuity. So we said perpetuity means unlimited withdrawals. In order to account for inflation, the payments are increased. So it's increased from the second payment onwards by 10% per annum effective. The present value of these payments at an interest rate of 16% per annum compounded quarterly is given by. Okay, so first thing, let's check if our effective interest rate, our effective growth rate, and our withdrawal period coincide. So here we can see that our R is a annual figure, our I is a quarterly figure, but our payments or withdrawal, so in this case it's a payment, not a withdrawal. So again, whether it's a withdrawal or a payment, it still works in the same manner. You can make unlimited withdrawals or unlimited payments into an account. Both of this have the similar concept, follow the same similar concept. So our payments are monthly, so they don't coincide. So to begin, let's work out a monthly growth rate and a monthly effective interest rate. So we're looking for I12 first. So it's 1 plus your effective interest rate, which is 16% compounded quarterly, so over 4 to the 4 over 12 minus 1. You will get about 0.013. Store that as A. Then your effective monthly growth rate is equal to 1 plus your 10%. So that is an effective rate, so we just substitute that in here because we need to substitute an effective interest rate inside anyways. All to the 1 over 12 minus 1. And you will get an amount of 7.974 times 10 to the minus 3. So store that as B on your calculator. Okay, now let's use our formula that we were taught. So here we have increase in unlimited withdrawals. So we're going to be using this formula. So your present value is equal to your PT, which is 100, over your effective interest rate minus your effective growth rate, which are both monthly. So we're just going to say A minus B because that's what we store them as on our calculator. So if you put that in your calculator, you'll get an amount of 19,285 and 42 cents. So you can see that in this example, they didn't want us to work out the final answer. They just wanted the format of how our workings or calculations would look. So before you always start a multiple choice question, always look at the options so you know where to stop and what exactly you need to look for. But in this case, I went further because I wanted to give you the final answer in case that is what you needed for your own understanding. Okay, so let's see. 100 over A minus B. So our A was our I-12, which we got by saying 1 plus 0.16 over 4 to the 4 over 12. Essentially, 4 over 12 is the same as 1 over 3, okay? Because in the options they have simplified. So 16% divided by 4 is 4%, so 0.04. So here, let's look for 0. So it's not A. Here they had the 4%, 1 plus 0.04. Okay, but so it's not C because C, the exponent is 4, whereas our exponent is actually 1 over 3 or 4 over 12. So it could be B, it could be D. 1 over 3 minus, then our B is 1.1 to the 1 over 12. So let's see, B is just 1.1. They don't show us the exponent of 1 over 12, whereas D, they do 1.1 to the 1 over 12. So D would be our final answer. Okay, in this multiple choice question, they didn't work out I-12 and R-12 separately and then do the present value formula. They did it all in one step. Okay, that's it for this video. Thank you.